hit go live. Okay, fantastic. So we are live. Welcome to NYC Python, the very first demo day. I'm going to go ahead and call the presenters in the order in which they will be presenting. And so, Greg, you will be up first. Just remember to introduce yourself, your project, as well as the types of roles that you're searching for before going ahead and
so we are live.
Starting.
Welcome to NYC Python.
Oh, sorry, now I can hear myself. 1 second.
Okay.
All right, Greg, 1 second before you start. Sorry, just employers, please remember if you would like to speak to a particular speaker, private message Anna. Just a reminder so she can get that set up for the networking part of it. Okay, thanks, Greg. The floor is yours. Go ahead.
Thank you. Can anyone see my screen? Great. So my name is Greg Feliu. I'm a former Flatiron student looking for data analyst, data engineering positions. And today I'll be presenting about how we can learn about Mexican immigration through restaurant names. So as everyone knows, there's been a huge influence from Mexico in the form of Mexican immigration to the United States. However, Mexico is a huge and diverse country. So what I would want to know is, do people from all over Mexico, have they immigrated to the United States in equal numbers? So are we learning about Mexico as a whole, or are we learning about Mexico from a very specific region? In order to look at this, though, there is no data set that clearly shows the region someone was born in and where they live in the United States. So in order to answer this question, I'll be looking at restaurant names and looking at the connections between a place mentioned in the restaurant name to a region of the United States. In order to do this, I'll first build a database of names, cities, and demonyms that refer to a region in Mexico. Next, I'll collect a database of Mexican restaurants in 4 US cities. Then I will match these restaurant names to regions in Mexico and interpret the results. The database of words referring to Mexican regions comes from different data sources. However, they're all combined into one Python dictionary where the regions are the keys to the dictionary. And then there's a long list of names that refer to that region. So for example, someone from Mexico would be a Mexican, so that's an example of a demonym that would be in a certain region. To show this process graphic, we have our data collected, cleaned, and then added to our dictionary. Next, I build a database of restaurants in US cities. Luckily for me, food inspection data is well maintained and thorough. And I took this from 4 US cities, New York City, San Francisco, Dallas, and Chicago, because all of them have large Mexican populations and they're from different parts of the country. So we get a somewhat representative view for Mexican immigration to all of the United States. Similarly, we gather the data, filter and clean the data, and combine into a single pandas data frame. Next, for the big meat and potatoes of the project, we will be matching the restaurant names to regions in Mexico. So we will split every word in the name of the restaurant and try and match it to a Mexican region and save the result. So now that we have all of our data together, we can analyze the results. The most important finding was that all regions were represented in almost every city. So there's no clear bias in terms of where someone was born in Mexico and where they moved to in the United States when they immigrated here. However, there was some clear connections, the most notable being Puebla and New York City, where nearly half of New York City Mexican restaurants are tied to a single region in Mexico. And chain migration is the answer there. To show this graphically, I split each city into a separate box, got the proportion of restaurants that referred to each region, and color-coded the results. So as we see for New York City, the yellow region is Puebla, and nearly every region is represented. This is more so for Dallas, which was the most equitable in terms of regions represented in their local Mexican food scene. However, it's not entirely clear that The connections I found necessarily reflect reality. So in order to double check my results, I gathered data of money sent back from the United States to Mexico, which gives us a clear family connection between people in the United States and Mexico. And what I found was that there's a clear correlation between the restaurants and the regions represented in my study and remittance data. However, the biggest challenge I faced in this project was determining if a match is legitimate. So tequila is in the name of many restaurants. However, it's usually referring to a drink and not a small town in Mexico. Overall, only about 10% of restaurants had a word in the name that connected to a region in Mexico. To conclude, there's a roughly even distribution of people from all regions of Mexico in the cities studied here. However, there are certain ties that are clearly shown by chain migration. Thank you.
Great, thanks so much, Greg. And I see the applause coming in. Kei, you're up. Did I say your name correctly? Just remember to introduce yourself, your project, as well as the type of role that you're searching for.
And just one more detail, I am sorry. And if anyone would like to talk to Greg, please private message me. Just a little reminder. Thank you.
All right, so I'm gonna share my screen. Can you all see my screen? Oops.
Ben, yeah.
Yep. Right. So hi, my name is Kai. In this demo, I'm gonna present ReproNets, reproducible named entity transliteration models. So I'm gonna talk about my background. I'm a machine learning engineer. I have an experience in research and backend coding, web programming. And I have a Master of Science in Data Science from the Graduate Center. I have 1 year of experience in developing natural language processing models for web application at startup. I won the second prize out of 110 submissions at a COVID-19 AI hackathon. I'm looking for a position where I can develop machine learning models for an application. So what is transliteration? Transliteration is the process of transferring the pronunciation of one word in one language into another. So this diagram shows an example. It transliterates English word Python into Japanese pronunciation. And my app, you can choose the number of predictions to get from the models. So I'm gonna present my application. So can you see the screen? I'm presenting my application. Awesome. Okay, so this is my application. So users can type English word. Let's say Rocky, and it transliterates Rocky in English into Japanese. And this application supports English to 6 different languages. So you can select transliteration of Rocky into Korean, and you can get the results. The main audience of this application is a researcher. They can compare predictions across different models, and model returns predictions with probability of sequences. This phonetizers is a machine learning model, and this transformer is a popular deep learning model, which achieves the state-of-the-art performance. So this is a web GUI, and I provide the public API, RESTful API to the system. So users can send HTTP request to my system, and it's gonna return the predictions as a service. So it transliterates Rocky into Japanese, and you can get predictions from all models instantaneously. So these are the interfaces to our system. So I'm gonna talk about software architecture of ReproNets. So this diagram shows the software architecture of ReproNets. I use microservice architecture to achieve scalability and maintainability. So these are the two interfaces. All the requests go to request handler, and request handler forwards the requests into machine learning models. And each machine learning model runs as an independent Docker container. So if I change this machine learning model, I don't have to worry about breaking, request handler or like the other like models. And I'm going to talk about future work of ReproNets. I think this application might have a business potential. So I'm planning to support more languages other than Arabic, Hebrew, Chinese, Japanese, Korean, and Russian. And I'm thinking about adding token-based authentication to access our system. And I am developing application using the public API. So users can access trained models to evaluate, they can scrape training data from the internet, and they can use the trained models to evaluate the quality of the data set. And this project taught me one important lesson, which is I was developing transformer by myself, but model achieved a good performance, but it was too slow. Then I found open source transformer written in C++. That
Hey, Kai, that's great. We are right at 5 minutes. So if anybody has questions about that C++ interface, please shoot Anna a message and we'll get you in a conversation with him later.
Thank you very much.
Great, thanks so much, Kai, and great job. Can you remind us what types of roles you're searching for? Oh, you're muted, sorry.
I'm looking for a position as a machine learning engineer.
Okay,
fantastic. I can use Python and Node.js.
All right, wonderful. Sasha, you're up next. Remember to introduce yourself as well as your project and state the roles that you're looking for.
Got it. Can you see my screen?
Sure can.
Hi, everyone. Welcome to my presentation. My name is Sasha Prokhorova. My background is in linguistics, electrical engineering, and data science and machine learning. I am a recent graduate from Mattis Bootcamp. I am looking for positions in data analytics and data science. And today we're going to talk about my senior project as a student at Mattis, where I investigate the coverage of women's issues by the New York Times historically. So I did the overall topic modeling in the recent years to make sure I'm not misrepresenting the New York Times journalism style. And the analytics that I did was most frequent terms, sentiment analysis, and I also did some data visualizations in Tableau. So I collected data using the archive API provided by New York Times, using the automated production-ready pipeline that I wrote. I did the generic topic modeling, and then I filtered out the articles about my topic based on keywords and headlines, and then I did the analysis. So what topics have been prevailing lately? In 2019 and 2020, newspapers talked about COVID, police brutality, race and gender, politics, and climate change, of course. So let's look at the most frequent terms based on the time frame. I pulled over 11 million articles in general. And once I did the filtering through the relevant keyword and name search, turns out only about 9,500 of the articles were relevant to my topic about women. So these are all the publications between 1950 and the present day. The y-axis here is in hundreds, thousands, and we can see the number of articles produced by the newspaper each year. We see there are some spikes and dips. And this graph shows the relevant publications. And as you can see, the y-axis here is measured in hundreds. So yeah, much less, the publications of the women's issues was much, much less. To put things into perspective, if we were to superimpose blue graph and the previous yellow graph, the blue graph just disappears. You can see that you could barely see the spikes in 2018 and 2019. So after looking through the articles and the data, I did realize that war may have translated into better educational and professional opportunities for women. Because a lot of jobs opened up, and those newspaper clippings, time-stamped in 1950s, talk about women joining Navy and women graduating from university and becoming doctors, which is incredibly heartwarming. I just wish it didn't take something as terrible as war to create better opportunities. So I also did a Tableau dashboard. The dashboard you're looking at the moment is a screenshot, but my dashboard is available on Tableau Public and is fully interactive. So if you do click on the keywords over here, the number of keywords per article is showcased per decade. So these bar charts do change once you do click on different terms. So let's look at the sentiment analysis. Like, can we actually pick up on the journalists' emotions based on the newspaper headlines and keywords? As we see, sentiment is mostly neutral, but it fluctuates. We do have some sentiment, some negative sentiment, because some articles cover very sensitive subject matter, such as violence against women. So we do expect the sentiment to be slightly negative in some years. So here is the overall sentiment, as we can see, mostly neutral with some positive and some negative, which is to be expected due to the subject matter. So what did we learn? Like, even though we can see that a lot of improvement has been done in terms of coverage of women issues, there's still more improvement that can be done. And this is a very good quote from Sheryl Sandberg, that in the future, there will be no female leaders. There will be just leaders. And equal media coverage and representation is important to create equality and equal opportunities for everyone. And this is what I plan to do in the future. I might analyze some comments and maybe even build a filter for detecting potentially toxic comments. I might do a network recommender and probably analyze more topics such as police brutality and climate change. This is my contact information. Thank you very much for listening. And please do not hesitate to reach out if you do have any questions. And if you want to see more code, it's available at the GitHub. And I did write an article on this topic. It was featured on Mediums Towards Data Science. Thank you very much.
Yay. Thanks so much, Sasha. Mason, you are up next. Please remember to introduce yourself, your project, and also the roles you're looking for.
Sure thing. All right, hi everyone. My name is Mason Ellard. I recently graduated with my bachelor's in economics as well as the METIS Data Science Bootcamp in December. I'm currently recruiting or seeking opportunities as a data scientist or a data analyst. And today I'll be presenting my project on predicting gentrification in the United States. So just a quick overview, the primary motivation behind this project is to allow policymakers to anticipate when and where gentrification is going to occur so that they can cater policy in those areas to prevent displacement. I used data from 2010 to 2018 from the American Community Survey for US Census tracts, which is the census geographical equivalent to a neighborhood. I'll go over data methodology, gentrification trends, and model performance. I originally created this model for the state of California, which I was able to do on my local using scikit-learn, pandas, and GeoPandas. I decided that I wanted to scale the model to the entire US, so I converted my pipeline to PySpark and launched it on a Spark cluster using AWS EMR service. So as you can see, I started off with a with data on every census tract in the US for each of the years from 2010 to 2015. I then looked at each of those years and I took every census tract that fell under the 10th percentile for median household income in their state during that year, and that gave me the eligible neighborhoods category here. I then looked at every eligible neighborhood and took the ones that jumped to the 20th percentile for median household income or increased per capita income by 20% within 3 years after being identified as eligible, and that gave me my gentrified neighborhoods. So my sample consisted of my eligible neighborhoods, and I was attempting to predict which of those neighborhoods would fall into my gentrified neighborhoods category. Some of the model features I use can be shown on the left here. Some of the notable ones, I created a feature on education where I analyzed the percentage of people over 25 that had at least a bachelor's degree. I also created features where I analyzed the percentage of the workforce that drove to work, walked to work, carpooled, took public transport, etc. I've shown some of the which features had a positive effect on a neighborhood's likelihood to be gentrified over here and which ones had a negative. Notably, education, the percentage of people driving alone to work and percentage of remote workers increased, a neighborhood was more likely to be gentrified. Also, you had some similar transportation metrics. One thing that's notable is that as median age went up, a neighborhood was less likely to be gentrified, suggesting that a younger population is gentrifying these neighborhoods. These are some of the feature importances from my random forest model, which was my best model. Some of the notable features are education surrounding remote workers and surrounding median age. These surrounding features are just features in the neighborhoods surrounding the one I'm trying to predict. These are notable because a common theory is that young educated millennials who are seeking high-paying jobs in tech, finance, and entertainment are driving the gentrification of a lot of major cities in the US. And that these millennials have high preferences for neighborhoods that are highly amenable, that give them access to retail and allow them to work remotely or close to work. And my model's emphasis on some of these features suggests that this theory, that this demographic is driving gentrification may be correct, and that their preferences for where they want to live may indeed be very indicative of whether a neighborhood will become gentrified. Overall, model performance wasn't the best. My random forest model was able to generalize better than my gradient boosted machine and neural net, but the data was noisy and I wasn't able to improve it actually by scaling to the US, though there were some key differences. So in California, I was able to assert some constraints on my data set that allowed me to get a 10% increase in precision. I've given a variation of the funnel diagram I provided earlier here with eligible neighborhoods at the top and constraints here. As you can see, I constrained my neighborhood data set to white majority neighborhoods in highly educated areas and put a minimum land area. And I was able to increase my results by 10% precision. Obviously, we shouldn't use this in production for ethical concerns, but it may be indicative of California's culture, economy, or urban planning practices, and definitely is an area for further exploration.
Thank you, Mason. That's great. If you want to talk to Mason anymore, I know you're pretty much at the end, but please reach out to him in our networking session.
Perfect timing, yes.
Perfect timing. And Mason, did you say what roles you're looking for?
Yes, I'm looking for full-time data scientists and data analyst roles.
Okay, fantastic. Julia Nguyen, first Julia is up first. And go ahead and introduce yourself as well as the roles you're seeking and your project. Take it away. You are muted though.
Yeah, sorry, I couldn't find my Zoom screen for a bit. Okay, hi, so my name is Julia and I'm looking for data science positions. Before transitioning into data science and completing the Metis Data Science Bootcamp, I completed a chemistry PhD at the University of Washington. And so today I will be discussing a model I've developed that can detect urban areas using satellite images as a strategy to measure urban sprawl. Why do we want to measure urban sprawl? First, let's define urban sprawl. Urban sprawl is generally associated with low density, auto-dependent growth and has many negative consequences. Greater car usage can lead to traffic congestion, higher carbon emissions, and increased air pollution. The spread of low density development also results in the loss of valuable wildlife habitat. Urban sprawl has even been tied to negative health impacts, as the increased car dependency and air pollution has been tied to things like obesity and respiratory problems. So given these negative impacts, it would be useful to be able to measure and keep track of urban sprawl and maybe find policies that can help counteract it. How is urban sprawl usually measured? Traditionally, it's been measured through land surveys. However, there are many drawbacks to that strategy. Land surveys are often expensive, they take a long time and may not be done very frequently, and there are often inconsistencies with categorizing urban areas. The development and growth in geospatial data has the potential to transform the way we study cities. Using satellite imagery to measure urban sprawl is relatively cheaper. You're able to get more granular data, and you are able to study cities on a more global scale with a lot of flexibility. My goal in this project was to develop a model that can detect urban areas using satellite images. This model could then be applied to satellite images of cities to measure urban sprawl. This is my workflow. First, I developed a convolutional neural network that can identify urban and non-urban areas using a labeled dataset. Then I collected Landsat satellite images using the Google Earth Engine API. I applied my model to satellite images of Seattle and Las Vegas to visualize and measure urban sprawl in these cities. To train my model, I used 27,000 labeled satellite images from the German Research Institute of Artificial Intelligence. This data was labeled with 10 different labels. I took those 10 subcategories and combined them to form 2 categories, urban versus non-urban. The images at the bottom are just some examples of images from this data set. For my model, I developed a CNN model using transfer learning with the FastAI library. I was able to achieve good accuracy, 0.94, in predicting the 10 subcategories. I looked into where the model was making mistakes, and these are 2 examples of errors the model made. For the left image, the model predicted vegetation when it's actually permanent crop. And for the right, the model predicted pasture when it's actually annual crop. These examples are pretty representative of the errors the model made. And considering that I was only interested in urban versus non-urban, it was pretty heartening to see that most of the errors were misclassifications between non-urban subcategories. And indeed, we find that when predicting between the 2 categories that I was interested in, urban versus non-urban, the model had an accuracy of 0.99 with relatively high precision and recall. As you can see in the confusion matrix, the model is able to label accurately a majority of the images. I next applied my model to satellite images of Seattle. For this satellite image of Seattle in 2020, I took the full image and split it up into much smaller tiles. This is an example of a tile I created. I then inputted the tiles into the model to determine whether the tile was an urban area or non-urban area. For this example tile, the model accurately predicted that it was an urban area. So now looking into urban sprawl, when we compare the greater Seattle area in 1984 versus 2020, we see that there's been 153% growth in developed area versus a 77% growth in population. So the ratio of urban growth versus population growth is 1.4 to 1. It seems that Seattle is undergoing urban sprawl and de-densification, which is a little disappointing because Seattle has enacted a lot of policies to discourage urban sprawl. Another city I looked at is Las Vegas, which saw a lot of growth from 1984 to 2020. There was a 634% growth in developed area and a 409% growth in population. The ratio of urban growth versus population growth is 1.6 to 1, which is a little higher than Seattle. And so it seems like Seattle is undergoing even more urban sprawl and de-densification than Seattle. So in conclusion, I developed a CNN model that can identify satellite images as urban or not urban with high accuracy. I applied that model to satellite images of Seattle and Las Vegas and found both cities are undergoing de-densification. Thank you so much for listening. If you have any questions, I can be reached at that email address.
Thanks so much, Julia. Did you say at the beginning what roles you're looking for?
Yes, I'm looking for data science roles.
Fantastic. All right, thank you so much. Let's move on to Julia Q. Go ahead and introduce your project, your name, yourself, and let us know what roles you're looking for.
Great. Can everyone hear me okay?
I can, and I can see your screen.
Perfect. Great. So I will get started then. Hi, everyone. My name is Julia Qiao, and today my project will be focusing on understanding who is the millennial homeowner by interpreting demographic characteristics via binary classification. A little bit more about me. I've worked in analytics in the travel and technology space for the past 4 years. I'm also a proud graduate of the Metis Data Science Bootcamp, and my career mission is really to use the power of data to help people and ideas fulfill their fullest potentials. I am currently looking for data scientist and data analyst roles. Let's talk about millennial homeownership. I'm sure that this is a topic that you've seen in the media. Homeownership is a cornerstone of the American dream and a large rite of passage. However, it's been well documented that millennials are lagging in terms of this rite of passage compared to previous generations. In the data I used for this project, which came from a 20-year longitudinal study conducted by the US Bureau of Labor Statistics, it was clear that millennial homeowners, defined by those who own their primary residences that are a house or apartment, were outnumbered by their renter peers 2-to-1. A little bit about model selection. As you can kind of see on my previous slide, I came into the project with a class imbalance problem. Some other challenges I faced was picking a algorithm to essentially conduct classification. There's often a trade-off between interpretability and predictive power when it comes to the variety of different models that you're able to use for classification. And although Random Forest had extremely high predictive power, was amazing out of the box on raw data, it did not have very high interpretability. And the goal of my entire project, thinking back to the business case, was to interpret all of the features, which is why I focused a lot using techniques like feature engineering, data imputation, as well as balancing class sizes to then create a final logistic regression model, the most interpretable, I think, of all the different classification models that matched the predictive power of Random Forest. As you can see here, I try to prioritize recall over precision, thinking about this through the case of a business objective. Obviously, for my own purposes, I was trying to interpret the millennial homeowner, but if a business were to want to reach out to any millennial homeowners, I knew that the opportunity cost of leaving out a true millennial homeowner, aka a false negative, would be much greater than the cost of reaching out to a non-millennial homeowner by accident, which is a false positive. Therefore, I was able to achieve a recall of 0.73 and precision of 0.55 in my final model. On to feature interpretation. This is my favorite part of the project. I think we often associate millennial home ownership with financial assets. However, going through the top 5 features impacting home ownership from the least to most impactful, we can see that race, level of education, impact a millennial's homeowner status. Financial assets do play into this, but it is not the top second or first feature that is impactful. The top 2 features were actually lifestyle features, relocations of primary residences, so the number of times the subject has moved since their teenage to year 30, as well as marital status, which is really interesting to keep in mind as it goes against some of what we've been thinking about and have seen in the media. I also created a Tableau, very interactive database to further understand the different subjects individually, as well as some of the top features. You can actually access that should you want to play around with it via my Medium article, which I published on this project. It was featured in Towards Data Science. And if you want to look a little bit at the behind the scenes code, feel free to check out my GitHub, and please feel free to reach out to me on LinkedIn if you have any questions or just want to chat about anything data science related in general. Thank you again for listening to my presentation. This has been Julia Qiao speaking.
Amazing. Thank you so much, Julia. So we're done with the Julia's portion of this presentation. I have next on my list, Yaakov. Are you ready to present? I cannot hear you. But good lip reading. No, nope. Uh-oh.
How about now?
Yes.
Oh my gosh, so annoying. I have these such fancy headphones and I can't use them for what I want to do. Okay. So I'm good.
Yes, you're good. Go ahead and introduce yourself.
All right.
As well as your project.
Yeah.
And make sure you state what kinds of roles you're looking for.
Yes. Okay. Hello, my name is Yaakov Bressler. I live here in New York City. I've been doing data science stuff that's south of the model. That's like a term I heard recently. So like the things that make the things work. And I guess that's the type of role I'm looking for. Like, I don't know, maybe it's called software engineering, but it's in data science. So we'll all figure it out together. I'm going to show y'all a real cool thing. If you don't already know it, then you're going to be like, so fun. I'm going to show you SQL Alchemy, an ORM. And they make really complicated things really simple. I wanted to make slides to like choose highlights, but I didn't. But I'll try to keep it as top as I can. I will say there's some good news. That I have a README in here that is so readable. Okay, this should be it. Okay, so I've got a README in here that will take you through this entire project. So you can do it on your own. And if you want this, this is a cookbook template that you can use to get SQL Alchemy started on your own. If you have not used it, then shoot me a link and I will get it to you and you will be able to start like creating your own databases and stuff. All right. So before we just get into it, like what is SQL Alchemy? Well, it's an ORM, which stands for Object Related Mapper, and it lets you interact with a database like a SQL table with Python. Yeah. So imagine someone says, all right, I just saw a Broadway show and I loved it. And I want to build a little app that lets me keep track of all the shows I've ever seen. And I want to be able to see all the people who have been in those shows because I want to obviously like make sure I saw the show with all the people I'm fans of. So you go and build an app. You're probably gonna have to open up a database and unless you're a whiz at it, it's very easy to mess up and create things that are messy. However, you've been programming Python for a while and you know how to write code and you know how to use classes. So here is the magic solution. You are going to be able to create a database entirely in Python. Maybe you'll have to like click a few buttons here or there. You'll do the entire thing. So I'm going to talk just from a top level, like some of my favorite parts of SQL Alchemy, and then we'll show it in action in one area. So my favorite part is probably how easy it is to define a model. So I have a few models here. I have shows, which are quite obvious, right? You got a show title, the date that it opened, the date that it really opened, the date that it closed, and then the genre, and then a few other things, where it was, and some internal fields. Let's go to the people in a show. All right, we'll keep this really basic because people are really complicated, and if you try to create a space for a person, like you're really going down a huge avenue. So here I just chose their names, and then I have a relationship here for the shows they've been in. And we'll go to the roles. Okay, name. So what does this look like? Like, all right, it's a lot of code, but what happens? So methods. I've got a cool little thing here. I've got this guy, which will create, no, that's the wrong one. Here, this guy, which will create, show up please, which will create an ERD. So I won't get into exactly what's happening here, but I will show you the results, which is going to be right. I deleted the results. Let me run it real quick so I can give us the results. You don't see the other window in my screen, but I do, and it is running. So give me a quick second. Methods, and then generate ERD. What is this called? Generate ERD. All right, there we go, magic. And this is what it does. It creates this little picture for you. So this ERD is an entity relational diagram. The resolution is not great, but here you can see the relationships that we just created. So I know that I've got, my favorite actor, and I've got the show they've been in, and here is the relationship that connects them. So pretty cool. And this is going to work on really large databases. You could have hundreds of tables, and it will generate that for you. So I'm going to show you one last thing, and then I think I'll just end a little early. If you want to populate your database, you could do it like using like proper methods, or I cheated and I created some empty records here. So I created a theater, I created 2 shows, and I added all the people in. Great. And then, and this is how it's added. It's a little bit intricate. There's not all best practices here. Some of them are, some aren't. Let's zoom in one tiny little spot. Okay, here we go. We're going to add a theater. I'm going to say, check my database for this theater. See if I found it. If I found it, say that you found it. Otherwise, go add your items and then add it. And at the end, finish up, close the connection. It's that simple. So that's as far as we'll go there. And then for one last little thing.
That's actually perfect timing, Yaakov. We're right at 5 minutes. If you have any more questions about MySQL Workbench, feel free to engage with Yaakov in our second half of the session.
Awesome, perfect. Okay, next up, we've got Harry.
All right.
Remember to introduce your project, yourself, and state the types of roles you're looking for.
Thank you. So my name is Harry John Shephard. I go by HJ. I am looking for data analyst roles, data scientist roles. Also, shout out to that product management role. I've been looking for some data product positions as well. And I started my journey into data last year. About this time last year, actually, I was taking my first classes in preparation for the Metis bootcamp I took last summer. And before then, I've had about more than a decade in the nonprofit sector, including mostly social services and some performing arts. So this for me is a chance to kind of bring these two together, because this is a dive into eating disorder cultures online. And right now, I actually still work at the National Eating Disorders Association. And while I've been working there, I've learned a lot about what the science has learned about eating disorders, what it hasn't learned, and also how they've done a miserable job of really communicating this to the greater public. So my hope is that maybe through an exploration of looking at an NLP analysis of some eating disorder communities, maybe I would find something that would prove that there's a good reason to do this on a larger scale, right? To try to like add to the research to better people and their chances of recovery. Eating disorders are quite prevalent, and they're also very deadly, but they also drive people into secrecy, which makes these online spaces that people have like found their tribes with here very valuable spaces to use as getting a window into the lives of these folks and their behaviors and their thoughts, right? And while there has been some research done, it's usually on a smaller scale between like a client and their therapist, right? More case study based, which doesn't have the same feel as people when they're really being their authentic selves with people they're relating to as peers. So where I wanted to go with this is I went to Reddit, where for people who aren't familiar is essentially a series of message boards. So I took 16 of these message boards or subreddits that were explicitly or indirectly related to eating disorders and took about 13,000 posts and the associated comments. Within all these words, this formed the whole corpus. And basically I found a sweet spot of 6 main themes that ended up becoming the topics that kept coming up over and over again. In a way of classifying each of the individual documents. So to look at these like 6 topics, going from top to bottom, we have the more negatively associated, more negatively recovery associated topics, going to like the cooler ones on the bottom, the cooler colors, which are the more positively recovery oriented topics. And these numbers that you'll see right here are the total amount of documents where that was the primary topic associated with it. So now to actually compare some subreddits to see if there's any differences, is there any patterns and trends? So this is 2 subreddits, one just called Anorexia Nervosa and one called Anorexia Recovery. And I wasn't sure if there would really be any meaningful differences, right? I thought at most maybe it could be maybe a few percentage points from positive to negative, and then also maybe something more formal, like this subreddit has more meme based and this one is more like journal entries that people use. But in fact, there was a 24% swing difference from the negative to positive associated topics going from this top subreddit to the second one, right? So what's going on here? Taking a closer look, there's actually a big difference in these 2 subreddits. The bottom one with the more positive recovery oriented topics is much more structured, has much more active and opinionated moderation, has explicit resources for people to get better, and also has less tolerance for the glorification of eating disorders. And this didn't happen just here. This happened again in two subreddits that are almost identically titled as well. There's only an underscore differentiating the titles. But in this case, there was, again, a significant difference, 19% swing from negative to positive, going from the top one to the bottom one. And again, it was the same story of more structure, more active moderation, and there's an actual culture that's steering people towards recovery. So what does this all mean and why does this matter? This matters because if these spaces are distinct, even though people talk about existing in many of them at the same time, then we know that there's like personalities they have. And if we can identify the facets of those personalities, then we can reference them to people's outcomes. If we can track the users in these spaces and seeing where they exist and how they end up doing in their journey to recovery, or perhaps if they even get worse, then we can better understand maybe what are sorts of environments and conversations and communities that can be preventative for people getting worse with their eating disorder. This is also a chance to have a more democratic way to actually learn more about eating disorders, since we can capture more folks that otherwise may not be picked up through the biases in research that have left out people of color, people with disabilities, or folks in the LGBTQ community historically from being a big part of this. So
actually, Harry, you're right at time. That's perfect. Thank you. If you have any further questions, feel free to connect with Harry in a bit.
Awesome. So our final presenter of the night, last but most certainly not least, is Neda, our event host / presenter. And so Neda, go ahead and introduce yourself, your project, as well as what types of roles you're looking for.
Sure. Just 1 second. Let me share my screen. Okay. Can everyone see my screen? Okay. Yeah, so hi everyone, I'm Neda and I'm currently open for data scientist and data analyst roles. A little about me, after earning my master's in math, I dedicated to applying my knowledge to real world problems, which eventually led me to enroll in the METIS data science bootcamp, similar to a few of the other speakers that we heard tonight. After completing the bootcamp, I continued working on self-designed projects, one of which I will share with you today, which is the personalized contraception recommender that I built. So let's start off talking about the why, the what, and the how of my project. Choosing the right contraception is an overwhelming task. Each method has associated side effects, such as weight gain, acne, severe depression, and anxiety, just to name a few. And on top of the different side effects for every method, there are over 100 types to choose from. And I have never met a person that found the right contraception for them on the first choice. And so I wondered if there was a way to get it right the first time. And this leads me to my goal. I want to ease the burden of choice for contraception users and their partners. To do that, I sought to build a first of its kind personalized recommender for users to interact with, built on previous reviews of real people that wrote about their experiences. And the tools I used to accomplish this are Beautiful Soup and Selenium to build my data set by web scraping, Pandas and NLTK for data cleaning, data manipulation, and model building, and Streamlit and Heroku for app building and deployment. So I started by scraping drugs.com for roughly 60,000 reviews of 112 unique methods. Most of the reviewers were extremely detailed about their experience, which can be seen in this example here. I've been miserable. Since I've had it, I've had horrible acne outbreaks. My mood swings are very bad and very strong, and I've had my period nonstop since I've gotten it. I'm switching birth controls because this is very negative towards my body. I don't recommend this birth control. So I pre-processed reviews like this by removing stop words, including all contraception names. I made all of the characters lowercase and then used unsupervised machine learning to uncover topics. Using NMF and TF-IDF vectorizer, I found 6 unique topics within the topic document matrix from the non-negative matrix factorization. The topics were side effects and consisted of weight gain, period problems, anxiety and depression, mood swings, decreased sex drive, and acne. And I then used the topic document matrix to build my recommendation model. Users input the side effects that they want to avoid, which enters a 1 in the place that corresponds to that same column from the topic document matrix. So as an example, the person who wrote the review that I read to you complained about period problems, mood swings, and acne. So they would select those side effects, and the vector would populate the corresponding entries with a 1. Then the algorithm looks for the lowest cosine similarity between that vector and the mean topic scores for each contraception and returns a recommendation. And I built an app for my recommendation model using Streamlit, and I deployed it on Heroku. And that is what I will be demoing for you all today. So it should, okay, here we go. So let's say this person would like to get a recommendation. They'll start by selecting that in the menu. And let's say that they are open to both hormonal and non-hormonal methods. And let's say that they are open to trying a pill, the IUD, or the implant. And then let's say in the past they've struggled with weight gain, with anxiety and depression, and with acne. And they'll select Get Recommendations. And then as you can see, for each method that they selected, they get a unique recommendation. But let's say that this person actually has tried Amethyst in the past, and let's say that they hated it. They can actually choose to remove Amethyst from their recommendations, and they'll get a new recommendation. And they can click on the link, and I know that seeing a 5.3 rating might kind of scare you, but it actually is about the average rating that any contraception gets on this website. The highest rating that any of them got was a 7. So 5.3 is pretty standard. And so as I mentioned, I deployed the app on Heroku, and it's currently live if anyone wants to try it out. And yeah, thank you so much for listening. And here's my LinkedIn, GitHub, and blog information. Feel free to screenshot and connect, and I would love to answer any questions during the networking session. Thanks.
Thanks so much, Neda. And so, Ridwan, do we have any special kind of ceremony in order to close the live stream and move into the next session?
Yeah, if you have confetti in your background, just like light that up right now as we end the networking session, or end the presentation and transition to the networking session. But thank you again to all the presenters. Fantastic job. And then we had the live streamers that are watching you guys as well. And then thank you for everyone watching the live stream right now. We will be ending it as we transition into our networking session, where we have the presenters and the employers talk one-on-one in regards to potential employment opportunities. So thank you again, live streamers.